Welcome everyone to Digital Learning by the Department of Collegiate Education. I am Manjunath CV, working as Assistant Professor at Government First Grade College, CS Pura, affiliated to Tumkur University. So this is session number 5 or video number 5 on the chapter Correlation Analysis, and in today's session we shall try to solve problems on Karl Pearson's coefficient of correlation under the shortcut method or indirect method or assumed mean method. All the three methods mean one and the same. In the previous session number 4, we had solved Karl Pearson's coefficient of correlation on the basis of actual mean method. So the difference between these two methods is that in the previous method we found out the actual mean and then we solved the problem, that is we found out the correlation. But here we are going to assume a value according to our own choice as the assumed mean. We will not be finding out the actual mean. So these are the two different methods under which we are going to solve problems in Karl Pearson's correlation coefficient. So this topic is a part of chapter 1, correlation analysis, in the subject quantitative analysis 2. So without wasting much time, let us straight away get into solving the problems on correlation coefficient. Well, in today's session, let us look into how to solve Karl Pearson's coefficient of correlation in the case of assumed mean method. So under assumed mean method, how do we solve problems on Karl Pearson's coefficient of correlation? This will be our agenda for this particular session. This is session number 5, or you can call it as video number 5 on the chapter correlation analysis. Now, this is the problem which I have already taken while solving problems under actual mean method. So the same question is taken wherein we have the data about the marks secured by the students in the economics subject and marks secured by the students in the banking subject. The objective of why have I taken the same question is because your answer has to be the same irrespective of whether you are solving it in the assumed mean method or you solve it in the actual mean method. Final answer has to be the same. There is no change. There is no question about that. Only the method of solving would be different. The calculation values will be different. But finally, when we calculate the correlation, that is R, it has to be same both in actual mean method as well as assumed mean method. Whether it is actual mean method or assumed mean method, final answer, that is correlation, has to be the same. So now let X represent the marks secured in economics and let Y represent the marks in banking. Therefore, I have jotted down the values of X and values of Y. And before proceeding further, let us have a look at what are the steps to be followed in the assumed mean method. Apart from step 1, rest all the remaining steps are the same that we followed while solving problems in actual mean method. So what is step number 1? In actual mean method, it was calculating X bar and Y bar. That is the average of X and average of Y. But here we are not going to calculate the average. We are going to choose any one value as the assumed mean. Now, how do we choose assumed mean? Which value should we choose? You can take any term as the assumed mean. Generally, we choose the values between the lowest value and the highest value in the given particular values. For example, in the marks secured in economics, the values start from 17, 23, 35, 47 and 48. Out of these values, you can choose any value of your choice. Or you can even choose a value which is not there here also. For example, you can take 40, you can take 20, you can take 30. It is left to your particular choice. Generally what we do is we prefer taking any one value among these value as our assumed mean. So that is the first step here. You can take any term as assumed mean, A for X series and B for Y series. A for X series and B for Y series. So here step number 2 is the same, finding the deviations of X from X bar and Y from Y bar. That is how we choose the deviations. Step number 3 remains the same. There we calculated X square. Here we will call it as dx square and dy square. And then step number 4, we had calculated product of x, y. Here we will calculate the product of dx, dy. And finally step number 5, we will apply the formula. So if you look at the previous method procedures and this method procedures, all the procedures are one and the same, apart from only the first step. There we calculate the mean, that is average, but here we randomly choose any one value as the assumed mean. Now out of these values, let us choose let me say 35 as the assumed mean A, and out of these values, let me choose 40 as assumed value of B. You can choose any values of your choice, as I said. So now there we had x, here we will call it as dx. dx is equal to x minus a, that is x minus, we have chosen a to be 35. Similarly, we have to calculate dy, which is y minus b. So here it is y minus b is 40, y minus 40. So dx, that is calculating the deviation from x, says 48 minus 35 plus 30, 35 minus 35, 0, 17 minus 35 minus 18, 23 minus 35 minus 12, 47 minus 35 plus 12. So these are the values: plus 13, 0, minus 18, minus 12 and plus 12. Similarly, let us find out according to step 2 what is the deviation of y, that is dy is equal to y minus b. So here we have chosen dy to be 40. So 45 minus 40 plus 5 plus 5, 20 minus 40 minus 20, 40 minus 40, 0, 25 minus 40 minus 15, 45 minus 40 plus 5. So we have taken the deviations from x and the deviations from y. Now let us calculate it. What is sigma dx equal to and what is sigma dy equal to? Now sigma dx, minus 18 minus 12 is minus 30, plus 13 plus 12 is plus 25, minus 30 plus 25, what we get is minus 5. So 13 minus 18 minus 5, minus 5 minus 12 minus 17, minus 17 plus 12 minus 5. Next, let us calculate the dy values. Here it says plus 5, minus 20, minus 15, minus 15, minus 15, minus 30, plus 5, it is minus 25. Now, let us go to step number 3, which says calculate dx square and dy square. So dx square, 13 13s are 169, 0, 18 squares are 324, 12 squares are 144, Again 12 squares are 144. So sigma dx square is equal to, when we start adding all these values, 169 plus 324 plus 144 plus 144, what we get is 781. Similarly, let us calculate dy square. dy square, 5 squares are 25, 20 squares 400, 0, 15 squares 225, 5 squares are 25. So 400 plus 225, 625, 650, 675. Sigma dy square is equal to 675. Now that we have got what is dx and what is dy, we will go to the step 4 in calculating dx dy. The next step is step number 4, which is calculation of dx dy. Dx is plus 13, dy is plus 5, 13 5s are 65, and the symbol remains plus. Plus into plus is plus. 0 into minus 20, 0, minus 18 into 0, 0, minus 12 into minus 15, minus into minus becomes plus, 12 into 15, 15 12s are 180, and plus 12 into plus 5, it is plus, 12 5s are, it is 60. So sigma dx dy is equal to 65 plus 180, 245 plus 60, 305. So now we have completed all the 4 steps, and now let us go to the 5th step, applying the formula. The formula of correlation, R is equal to n sigma dx dy minus sigma dx into sigma dy divided by square root of n sigma dx square minus sigma dx the whole square into square root of n sigma dy square minus sigma dy the whole square. Well, this is the formula for calculating coefficient of correlation in the case of assumed mean method. Under direct method, if you observe, the formula was, under direct method, it was R is equal to sigma xy divided by square root of sigma x square into sigma y square. This was the formula under which method? Under the direct method. But under the assumed mean method, the formula for calculating coefficient of correlation is R is equal to n sigma dx dy minus sigma dx sigma dy divided by n sigma dx square minus sigma dx the whole square into square root of n sigma dy square minus sigma dy the whole square. Now let us substitute all the values in the particular formula. R is equal to n. How many values are there in the x series? 1, 2, 3, 4, 5. So the value of n is 5 into sigma dx dy. Sigma dx dy is 305. So sigma dx dy is 305 minus sigma dx. Value of sigma dx is minus 5 into value of sigma dy is minus 25. Sigma dy is minus 25 divided by square root of n, which is 5, into sigma dx square. Sigma dx square value is 781. So sigma dx square, which is 781, minus sigma dx, which is minus 5, minus 5 the whole square into square root of n sigma dy square. N is 5 and sigma dy square is 675. So sigma dy square is 675 minus sigma dy, which is minus 25 the whole square. Next, r is equal to 305 into 5, 5 5 is a 25, 2 5 3 is a 15, 1525 minus minus 5 into minus 25, minus into minus becomes plus, 25 5 is a 125. Divided by square root of 781 into 5, 5 ones are 5, 5 eights are 40, 35 plus 4 39, 3905 minus within brackets minus 5 the whole square, that is minus 5 into minus 5 becomes plus 25. So when we remove the brackets, minus becomes plus into square root of 675 into 5, 5 5s are 25, 35 plus 2 37, 30 plus 2 32, 3275 minus minus 25 the whole square, minus into minus plus 25 into 25 625. So 3275 minus 625. Next, r is equal to 1525 minus 125, it is 1400 divided by square root of 3905 minus 25, that is minus 25, which is 3880, 1880 into square root of 3275 minus 625, which is 2650, 2650. And now I'll further continue here due to shortage of space. So r is equal to 1400 divided by 3880, square root of 3880, 62.28 into 2650, square root of 2650, 51.47. R is equal to 1400 divided by 62.28 into 51.47, which is 3205.55. Therefore, R is equal to 3205.55. It is 0.4367. So roughly we can call R is equal to 0.43. Now, what is the answer we have got? The answer that we have got, Karl Pearson's coefficient of correlation is equal to 0.43. So therefore, the answer correlation coefficient is equal to 0.43. Now, if you remember the direct mean method or the actual mean method when we solved, again we had the answer as 0.4286. The third decimal is 8, which is 5 and above. So we rounded off the next 0.42 to 0.43. That was the value of the R in which method? The direct method. Now, what is the final answer in the case of actual mean method? I mean assumed mean method if you observe, again the value of correlation is 0.43 and actual method also answer is 0.43. So if you observe, the method may be either assumed method or it may be the direct method or actual method. The final answer remains the same. R is equal to 0.43. So from this we can conclude that the correlation is slightly positive between the marks scored in economics and the marks scored in banking. Therefore, this is how we solve a problem under assumed mean method. So once again, let us have a recap. 5 steps. The last 4 steps are the same. Only the first step changes. In case of actual mean, it was finding out x bar and y bar. Here, in the assumed mean method, we do not find mean. We assume any value to be mean, that is A and B. A for x series and B for y series. Step number 2, we calculate the deviations dx and dy from assumed means A and B. Step number 3, we calculate dx square and dy square. And step number 4, we calculate the product of dx, dy. And finally, step number 5, we apply the formula. So accordingly, our answer is 0.43, which is the correlation coefficient. So I hope you all have understood how to solve a problem in the case of assumed mean method. Okay, now let us look at one more problem as to how to solve the Karl Pearson's coefficient of correlation in the assumed mean method. Just now we have done one problem based on the assumed mean method, and this shall be the second problem on the basis of assumed mean method. If you carefully observe the problem, this is the same problem that I have chosen to be solved under actual mean method. So as I said in the previous session, whether it is an actual mean method or assumed mean method, the final answer, that is the correlation, will be one and the same. Only the method is different, the values may change while computing, but final answer, the final correlation has to be one and the same. Now without wasting much time, straight away they have given us 2 variables, one x and the other one is y. So we need not define what a variable represents what. Directly they have given us the variables. So I have noted down the variable x and variable y. Before I continue further, let us have a recap at what are the steps to be followed in case of assumed mean method. Step number 1, take any term as assumed mean. A for series x and B for series y. You can choose any number out of these values. In the last case, in the last previous problem, I had chosen different numbers for both A and B. But in this case, I'll choose the same value for both x and y. In case of x, I will choose A to be assumed mean to be 16, and in the case of y also, I will choose the assumed mean to be to be 16. If you look into the previous problem, there I had chosen 35 for A and for B I had chosen 40. I had taken different assumed means. Here I am going to change the method here, and I am going to select the same value in both x and y. As I have already told you, you can choose any number out of your choice, any number as per your choice. Therefore, whatever may be the number of your choice you are choosing as your assumed mean, the final answer should be the same. Please keep this in mind. Now, that was step number 1. Step number 2 says find dx, that is deviation of x from assumed mean, and deviation of y from assumed mean. So that is dx and dy. So let us begin with dx. Dx is equal to x minus a. In this case, x minus 60. Since our assumed a is 60, mean is 60, we are going to take a as 60. So 55 minus 60 minus 5, 56 minus 60 minus 4, 57 minus 60 minus 3, 58 minus 60 minus 2, 59 minus 60 minus 1, 60 minus 60 0, 61 minus 60 plus 1, 62 minus 60 plus 2, 63 minus 60 plus 3. So this is x values minus the assumed mean, which is 60. So sigma dx is equal to 3 plus 1, 3 plus 2 5, 5 plus 1 6, 6 minus 1 5, 5 minus 2 3, 3 minus 3 0, 0 minus 4 minus 4, minus 4 minus 5, it is minus 9. So sigma dx, the value of sigma dx is equal to minus 9. Sorry. Similarly, let us find out what is the value of sigma dy. So deviations of y is equal to y minus the assumed mean, which is b. So here it is y minus, again I have taken the assumed mean here as 60. So y minus 60. So y minus 60, 58 minus 60 minus 2, 59 minus 60 minus 1, 57 minus 60 minus 3, 60 minus 60 0, 63 minus 60, it is plus 3, 64 minus 60, it is plus 4, 62 minus 60, it is plus 2, 63 minus 60 plus 3, and here again it is 63 minus 60, which is plus 3. So sigma dy is equal to 3 plus 3 6, 6 plus 2 8, 8 plus 4 12, 12 plus 3 15, 15 minus 3 12, 12 minus 1 11, 11 minus 2 9. Here it is plus 9. Sigma dx is minus 9, sigma dy is plus 9. So we have completed the second step. The first step is taking any term as assumed mean. We have taken the assumed means to be 60 in case of A as well as 60 in the case of series Y. Second step was we calculated the deviations of the assumed mean from X and the deviations of assumed mean from Y. Now we are going to find out the squares of these deviations, dx square and dy square. Now dx square, 5 squares are 25, 4 squares are 16. I've told already, when you square a number, the symbol, if it is minus, it will become plus. Minus into minus becomes plus. 3 3s are 9, 2 2s are 4, 1 1s are 1, 0, 1, 2 square 4, 3 square 9. So next we have sigma dx square is equal to what? Sigma dx square is equal to 9 plus 1 10, 14, 15, 15, 19, 28, 38, 44, 49, 59, 69. Therefore, sigma dx square is equal to 69. Similarly, let us find out what is dy square. 2 squares 4, 1 square 1, 3 square is 9, 0 square 0, 3 square 9, 4 square 16, 2 squares 4, 3 squares 9, 3 squares 9. So next let us find out what is sigma dy square. Sigma dy square is equal to 4 plus 1 5, 5 plus 9 14, 14 plus 9 23, 23 plus 16 39, 39 plus 4 43, 43 plus 9 52, 52 plus 9 61. So we have come to the step number 3, which is finding out dx square and dy square. So we have computed dx square and also dy square. Next, let us calculate step number 4, that is finding out dx dy. That is the product of dx into dy. I'm sorry. So dx and dy is here. Minus 5 into minus 2, minus into minus plus, 5 into 2, 10. So we are computing the step number 4, which is dx dy, product of dx and dy. Second, dx is minus 4, dy is minus 1, minus into minus plus, 4 ones are, it is 4. Dx is minus 3, dy is minus 3, minus into minus plus, 3 into 3, 9. This is also plus. Next, minus 2 into 0, anything into 0 is a 0. Minus 1 into plus 3, minus into plus is minus. 3 ones are 3. 0 into 4 is 0. Next, plus 1 into plus 2 is again plus 2. Plus 2 into plus 3 is 2 3s are 6, so it is plus 6. 3 into 3 both are plus, 3 3s are 9. So this is sigma dx dy is equal to 10 plus 4 14, 14 plus 9 23, 23 minus 3 20, 20 plus 2 22, 22 plus 6 28, 28 plus 9 it is 37. So the value of sigma dx dy is equal to 37. So with this we have completed 4 steps. Steps number 1, taking the assumed mean. Step number 2, calculating dx and dy. Step number 3, calculating dx square and dy square. And finally step number 4, finding out dx dy. Now after this we shall proceed and apply the formula of correlation. Under which method? Under the assumed mean method. R is equal to n sigma dx dy minus sigma dx into sigma dy divided by square root of n sigma dx square minus sigma dx the whole square into square root of n sigma dy square minus sigma dy the whole square. So this is our correlation formula in the case of assumed mean method. So now we have all the values of dx, dy square, di, etc. So let us substitute those values in the particular formula. So r is equal to value of n. The total number of terms in the series x is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So value of n is 9 into sigma dx dy is equal to 37 minus the value of sigma dx is minus 9 and the value of sigma dy is plus 9 divided by square root of n is 9 into sigma dx square. The value of dx square is 69 into 69 minus sigma dx, we know it is minus 9, therefore it is minus 9 the whole square into square root of n sigma dy square. The value of n is 9 into dy square, the value is 61 and 9 into 61 minus sigma dy, it is plus 9, it is plus 9 the whole square. Let us further simplify. R is equal to 9 into 37, 9 7s are 63 6, 333 minus 9 into plus 9. Minus into plus is minus 9 nines are 81 divided by square root of n into 69. 9 nines are 81. 8, 54 plus 8, 62. 621 minus minus 9 the whole square. Minus 9 into minus 9 becomes plus. So 9 nines are 81 into square root of 9 into 61. 9 ones are 9. 9 6 are 54 minus plus 9. 9 nines are 81. So now R is equal to 333 minus into minus 81. That becomes 333 plus 81. Therefore 3 plus 1 4. 3 plus 8 11. 4 plus 1 4. 414. R is equal to 414 divided by square root of 621 minus 81. 1 minus 1 0. 12 minus 8 4. And 6 becomes 5. 540 into square root of 549 minus 81. 9 minus 1 8. 4 minus 8 6. This becomes 4. So next, I'll continue here further. R is equal to, the numerator is 414. 414 divided by square root of 540. 540. Square root of 540 is 23.23 into, next, the square root of 468, it is 21.63. So R is equal to 414 divided by 23.23 into 21.63. So value of R is 502.46. Therefore R is equal to 414 divided by 502.46. Value of R is equal to 0.8239. So when we bring it down to two decimal places, the third decimal is 3, which is less than 5. Therefore R is equal to 0.82. Therefore, what is the answer required? They are asking us to calculate the Karl Pearson's correlation coefficient between X and Y. I'm sorry, in the shortcut method or assumed mean method. There are three names: shortcut method, assumed mean method, and indirect method. All these three mean one and the same, that is assumed mean method. So here the correlation is 0.82. Now, if you recall, in the previous session, that is session number 4, we had solved the same problem under the direct method. Under direct method, again the value of R was 0.82. So whether it is a direct method or whether it is an indirect method, as I said at the beginning itself, the final answer, that is correlation, has to be the same. So let's have a small recap of what we have done in this particular solution. We begin with our steps of calculation. Step number 1, take any term as assumed mean. I have chosen assumed mean to be 60 for both series X and series Y, that is variable X and variable Y. This A and B, the choice is left to you. You can choose any value of your choice. Second step, finding dx and dy. So dx is nothing but deviation of x from the assumed mean A, and similarly deviation of y is equal to y minus assumed mean for series 1. Step number 2, dx and dy. Step number 3, we calculate dx square and dy square. We are squaring the deviations of x and we are squaring the deviations of y. And step number 4, we find out the product of the deviations of x and y, that is dx into dy. And step number 5, finally, we're going to apply the formula. So when we apply this formula and substitute the values correspondingly, we get the correlation to be 0.82. So what is the interpretation that we're getting is that the correlation is first of all positive. I repeat, the correlation is positive. If there is no symbol here, it means it is a plus. So the direction of the correlation is positive. And what is the degree of correlation? So what is the mathematical value given to that correlation? It is 0.82, and 0.8 is close to 1, and hence there is a strong positive correlation between the variables x and y. So this becomes your interpretation. This becomes our interpretation that there is a strong positive correlation between variable x and variable y, which means when the value of x increases, there are 80% or 82% chances that the value of y also increases. So if you observe here, when x increases from 55 to 56, the value of y also increases from 59 to 58 to 59. So like this, if you keep observing, generally the values are moving more or less in the same direction, either towards upwards or towards downwards. So dear students, I hope you all have understood thoroughly how to calculate Karl Pearson's coefficient of correlation in the case of assumed mean method as well as actual mean method, which was done in the previous session, that is session number 4. So with this, we come to an end of calculation of Karl Pearson's coefficient of correlation. So in the next coming session number 6, that is video number 6, we shall discuss about what do we mean by probable error, how to calculate probable error, a few basic problems on calculation of probable error, and an introduction to Spearman's rank correlation. So that's all for today's session. Thank you all.